So this is session number 3, Security in a Containerized World with Docker Enterprise, with myself, Oliver Pomeroy. So starting out on just a quick recap, just to make sure everybody's starting out on the same page here. Just a quite quick reminder, containers are not virtual machines. They are different. If you try and treat a virtual machine, try and treat a container like a virtual machine, you're not going to get too far. A container is your application code and the binaries and libraries required to run your application in a package, in a unit that can be distributed around and started on a modern host. The idea being that you can start to run multiple applications in their isolated environments on the same operating system, reducing the amount of infrastructure required to run your applications, and providing a really lightweight packaging format to distribute your applications between hosts. You can run containers on physical servers, you can run containers on virtual machines, you can run containers on cloud instances, or you can absolutely mix and match as this diagram shows. One of the key concepts around Docker and the Docker Enterprise Platform is that we're talking here about any application running on any operating system on any infrastructure. One of the key visions for Docker and the Docker ecosystem. Whether you are a developer, whether you're an operator, whether you're working with traditional applications, microservice applications, more modern things around blockchains or serverless, no matter what you're working on, containers can abstract you from the underlying operating system and the underlying infrastructure. And there are 3 core principles that we build into all of our products here at Docker. They are choice, agility, and security. Throughout the webinar series, we're actually working our way through those 3 pillars, the last one being choice, this one being security, and next in 2 weeks' time, we'll have a look at agility. Inside of each pillar, there are a variety of different things inside of our products that enable that particular vertical. In this one, we're diving into security. So we're looking at how we've built in security at every layer of the containerized stack, how you can integrate security when developing software as integrated directly into your software supply chain. We start to look at the chain of custody involved in sort of managing container images, and then looking at how we start to apply governance and controls on container platforms when starting to run applications in containers in production. Previously, we looked at the variety of different use cases involved for containers and for Docker Enterprise, whether that's modernizing traditional applications by lifting and shifting them into containers, whether that's using a container as part of your cloud strategy to move workloads from on-premise into the cloud and avoiding yourself being locked in once you get there, whether that's starting to reduce your data center footprint or reduce your data center expenses as you can consolidate infrastructure with containers, using containers to develop software and deliver software quicker, starting to modernize that supply chain and start to apply security controls around it, or start to deploy software at the edge and how containers can help you deploy software at remote sites, even in more trusted ways. In this particular webinar, we're going to focus in on these two use cases around how through containerization we can secure the software supply chain and how through containerization we can secure software being delivered out at the edge. And one of the key things, one of the key pillars I want to get through throughout this talk is that there is security at every stage with Docker Enterprise. Whether you're starting at the developer side or starting at the operator side, we're going to look at how you can secure development of containerized images, how we can look at securing the content, and so securing the container images through their transition from developers to operators, and look at how as an operator we can secure the applications running in production through various controls built into our platform. So starting with securing software development. And actually, I wanted to take a couple of minutes here just to make sure that people are aware of some of the security controls around container images when developing applications into them. There's a kind of a lot of myths out there today that containers are insecure, or running applications in containers today is insecure. And I wanted just to kind of cover off some of the core concepts around containerization, which provide security by default, that you get to take advantage of the second you run your application inside of a container image. So the first question, I guess, is often asked is what runs inside of a container? Now, we've run the first webinar in the series, we covered this in a bit more detail, but a container or a container image is a layered root file system. All it is a root file system packaged up and distributed around. We're not shipping core parts of an operating system like a kernel or a networking stack. In reality, just the layers of a file system that make up your application. Look at this in a little bit more detail. Kind of layer one may be the Ubuntu file system. Layer two, you may start to run and patch that operating system, and as you can see that they are clearly separate layers. And then maybe layer three, you install a package. In this example, Nginx, but you can start to see how every time a different function is called in this particular container image, we've broken that out into separate container layers. Now, one of the key concepts around container images, and one of the key security benefits you get around container images, is that those layers are read-only. When the container image starts and starts running on a host and on an operating system, those original 3 layers that you saw me build up on this slide are locked and are read-only. Now, there is a read-write layer on the very top, and you could provide persistent storage to your application by mounting in existing volumes. But the core concept of your application is running read-only. So what does that mean? Well, it means that every time you start your container image, it will start up exactly the same way, because all of those read-only layers aren't changing from container 1 to container 2. If for whatever reason somebody compromises that container image, and you start to then worry about whether that container image has been compromised and can't start anywhere else, that's absolutely not true, won't be the case, because they are read-only. If one particular container got compromised and you killed it, removed it, threw it away, the second you started up that container image again somewhere else, then a hacker or an attacker would have to find their way back into the container image. All of their previous exploits, all the previous changes they made to the file system would have been made in this temporary thin read-write layer at the top here, which gets thrown away. All of your application code lives in these read-only layers, which will not change no matter what people are doing at the top. As well as that, on the question around are containers secure, as part of the core container runtime, the Docker engine, as part of the core concepts of what a container is, they are secure by default, and everything is opt-out. 2 core concepts around containers is something called a namespace, which lives low down inside of the operating system, and something called control groups. Now, a namespace isolates what a container can see. And what I mean by that is that if you're in the container file system, you won't be able to see things from the host unless they've been mounted in, because they're in a completely separate namespace. This applies the same for the networking stack. This applies the same for things like users and user permissions. And control groups isolate what a container can use. So if you start up a container and say, you only get access to 2 gigs of memory, then that's all it'll have access to. Those are kind of core concepts of what a container is, a namespace and a control group. We then start to harden containers with some concepts low level in the operating system. Now this is here on the Linux side on this slide, but similar concepts apply on the Windows and the Windows container side as well. And on the Linux side, for example, we have this idea of capabilities, and that prevents what system calls a container can make. And so right out of the box, there is a whitelist of available system calls that a container can make, but the majority of all of the, I guess, malicious system calls that a process can make have been disabled. So you could argue that the process is actually safer, or your application process is safer running in a container then out of their container, because we've actually locked down all of those system calls straight away. As well as that, we apply things like AppArmor and SE Linux controls, depending on whether you're running on a Debian-based or a Red Hat-based operating system, and they can prevent what the container can actually do on the host file system. So if you are starting to mount things into container images, maybe for persistent data or persistent volumes, there is a whole new level of permissions around what a container can and can't access. The point of this slide here is really to emphasize that there are secure defaults enabled in containers that are there today running out of the box. You may not need to know exactly how they work or how to tune them. Trust the fact that they're there, they're hardened, and your application is safe running in a container image. So rolling back a little bit to how to start to develop containers securely, or how to create a secure environment to start to develop containers in. At this point, I want to talk about a product that we have called Docker Desktop Enterprise. Now, developing containers locally as a developer can be done on a few different tools. Docker today have been making a product called Docker Desktop now for a couple of years, and that provides a place a developer on his local laptop can start to create container images and then start to push them or share them with the wider teams or push them over to operations. However, there's been no real way to secure the development environment that the developers are working on until now. So Docker Desktop Enterprise provides a secure, safe environment for containers to be worked on locally on a Windows 10 or on a Mac machine. If you are part of the operations side, you now have a way to roll out this software development environment locally. So on the left-hand side here, we can now show how Docker Desktop can be rolled out via a service desk using mobile device management solutions, which is something never before seen in the container world. In sort of the desktop products of old, you have to have admin privileges on the laptop. You'd have to double-click an exe to install a development environment. We now have a centralized place for IT operations to roll out safely a software development environment for you to start to package up applications as container images. And at the same time, we also have a way using Docker Desktop Enterprise for you to lock down that development environment. There are now controls that can be managed centrally, whether you're sort of limiting, I don't know, the proxies that a developer could use, or the amount of resources that they can consume on their machines, or even to the point of what container images they start to build on top of. IT operation teams can start to lock down the development environment to provide control, not to restrict functionality, but to provide control around what applications or what container images can be produced. Now, once a developer has packaged up their application as a container image, the next question becomes, well, how do you start to secure that content? How do I start to move that container image around an environment securely? And how do I start to, I guess, provide layers of security on top of that artifact? Now, the first thing that we can do inside of Docker is that we can sign container images. Now, signing container images is the process of a publisher digitally signing using cryptographic keys who built that container image. So if you're a developer, for example, working on Docker Desktop Enterprise, and you've built a container image, when you share that container image up to the centralized registry, you can sign it with your cryptographic key. You can say, hey, yes, I've seen it, and I've signed it. This is all part of some technology that we have called Docker Content Trust. It comes in a few different ways, but it provides the ability to sign container images, provides the ability to store container images inside a registry, and it provides the ability to verify those signatures when you actually want to start to use container images. We'll get onto more of the verify and the operations side, but now I want to focus a little bit on signing and storing. So why is it so important to sign the container images that you produce? Well, a few different things. First of all, it ensures that there is freshness of the container image. And what I mean by that is that if for whatever reason a container image is invalid, maybe it's expired, maybe new versions have been rolled out and developers want to stop you using previous versions, you can actually expire or remove cryptographic keys from container images. Therefore, if an operator wants to start to deploy that application, it would come up with an error as part of the runtime verification to say the image or the signature attached to that image has expired. Also, one of the key things around signing container images is it ensures that the content you created, or ensures the operations teams rather, are using content created by the correct publishers. If you wanted to lock down what container images were deployed inside of your environments, or if you wanted to lock this down to a certain group of publishers, this can all be achieved with signing. Stopping operations teams using container images from the internet maybe, or from sources, publishers, users that they don't trust. You can now say that every container image running on my cluster has come from those two publishers that I trust. The idea of storing, so the signing of container images is done by Docker Content Trust. And that can be done when you build a container image. So that can be done on Docker Desktop Enterprise. It could be done on sort of as part of your pipeline, your CI tooling, things like that. The second step in the process is actually storing the image signatures. We all know today that container images are stored in a registry. And whether that registry is a public registry like the Docker Hub, or a private registry like the Docker Trusted Registry, we also need to have some bits on the side to actually start to store the cryptographic keys that have signed container images. As part of Docker, that store is Notary. Notary is a project that's part of the CNCF. It's a kind of a core security pillar inside of Docker Content Trust. And as part of our public registries in the Docker Hub, or our private registries and Docker Trusted Registry, where every time you push an image with a signature, we will store the image in the registry side, and we will store the signing and the cryptographic keys in the Notary server side. One of the second core concepts of securing content in container images, not only signing it to verify where it's come from, but a second, even more important possibly, concept is the idea to scan container images to make sure that what's inside of them is secure, is clean, is kind of ready to run in production. As part of the Docker Trusted Registry, we have the ability to scan container images for vulnerabilities. There is a scanning engine built inside of the product. So every time you push an image to the registry, it can be scanned for vulnerabilities. The scanning engine here is not checking the code in terms of vulnerabilities in the developer's code. Instead, at a binary level, we are going through the container image, seeing what libraries and binaries are included, and scanning those for vulnerabilities. The way that kind of works, so a developer will push an image up to the registry, up to DTR. We will actually break down a container image into its individual layers. We talked a little bit about layers before as a way that to construct a container image. And what we will do is we will inventory out all of the components. So for example, in layer number 1, we've inventoried out there's OpenSSL inside of that file system and there's BusyBox inside of that file system. In layer number 2, there was an Nginx package. And layer number 3, there wasn't any new binaries and libraries. That was actually just a syntax as part of a Docker file. Once we have this inventory, we will then compare it against a local CVE database. So every day inside of Docker Trusted Registry, we'll go out to the internet if it's an online environment, or a vulnerability database can be uploaded manually in offline environments. And we will compare this inventory against that vulnerability database. So for example, if we had a look for a database and said OpenSSL version 2.1 has a vulnerability, we will flag that this container image is insecure. It has a vulnerability, and it's up to you as an operator to decide if that's something you want to take forward into production, or if you want to go back to the developers and say, please go and patch your container images. They contain vulnerability X, Y, and Z. All of these results are published in a report. So the report is available inside of the user interface, or it can be exported out via JSON or via a CSV format. So you can clearly list out all of the vulnerabilities associated with a container image. And then you can start to build automation around this. So a kind of a good concept may be that if you're working with a CI/CD pipeline in this particular environment, Jenkins, but there are many different automation tools that work with Docker Enterprise. You could have a workflow that looked a little bit something like this. New code lands inside of source control, maybe lands inside of GitHub. Your pipeline tool knows that every time a new commit lands to build a container image. When the container image has been built, push the image off to Docker Trusted Registry. At that point, Docker Trusted Registry will scan that image. So every time a new commits land, we've now got a new container image, we will scan that for vulnerabilities. At that point, you could say, well, if there are no vulnerabilities with the container image and you're happy to move it forward into the testing phase, then the registry can handle that level of automation and can then fire off maybe a notification to back to the pipeline to say, all right, we're now working with clean container images. I want you to carry on the rest of the testing process and rest of the software supply chain. In this environment, the registry will call back out to the pipeline and start running some QA on a container image. When all the QA has passed and succeeded, goes off to the security team for one final manual approval to push a container image into production. And this is the production part of the registry, maybe not production rollout, not the CD side, more of the CI side. And at the same time as the security team verifying the container image and manually moving it off to the production registry, they would be signing it. And so now inside of my registry at the end here, I have a container image that is completely clean of vulnerabilities. So I'm not worried that there will be compromised packages inside. And it contains the security team signature. Therefore, I now have a publisher I can trust, being the security team. And I know that it contains no vulnerabilities. And at that point, I'm quite happy that the container content that I've produced is secure. We'll have more of it integrating Docker Enterprise as part of the pipeline inside of the Agility webinar in 2 weeks' time. So let's have a demonstration of some of the secured content in action. So jump out of the slides. And the first thing I'm going to do is I'm going to be using Docker Desktop Enterprise. So we talked about Docker Desktop Enterprise as a secure way to develop containers. You can see here on my laptop, I'm running the latest version of Docker Desktop Enterprise. And this has been rolled out to me by my operations team. A quick look in the settings menu of Docker Desktop Enterprise, you can start to see that some of the operations team have started to lock down things that I can customize inside of my development environment. For example, they don't want me to start moving around with proxies, maybe giving myself access to blacklisted registries or something like that. So they've actually locked down the ability to configure. They may have also gone in here and said, well, I don't want to start you maxing out your corporate machines. I'm going to lock down the amount of resources that you can dedicate to this. And there are many different things inside of here that I can start to lock down as an administrator. Maybe lock down the version of Kubernetes that someone could use, for example. So now that I have my development environment, and my development environment is sat here running locally on my Windows 10 laptop, I'm going to start creating container images and then pushing them forward to the registry. So here I have a terminal session. It's connected to my local Docker desktop enterprise environment. And I'm going to work with a demonstration app. It's a pretty simple demonstration app. If you've seen the rest of the series, you'll know it's the cat demonstration. And so what I'm going to do is I've been working on this locally. I'm now ready to build this as a container image, and I'm willing to share it. So we've seen this done via a Docker build command. So I want to Docker build this. Call it cat demonstration. And we'll give it a tag of number 3. All right, that's just packaging up my application as it is in my local file system inside of a container image. A couple of minutes just to download all the prerequisites and build my container image. Great, it's now built. Now I want to push it. I actually want to distribute my container image from my local environment up into my registry, my private registry. But I want to do something slightly different than I've done in some of my previous demonstrations. I actually want to sign this container image as one that I've built and that I'm happy with. Now, I'm going to do that with a new set of commands called Docker Trust. Docker Trust is a way for you to distribute cryptographic keys as part of the signing process. It's also a way for you to push signed container images. So here I'm going to do Docker Trust sign and put in the same container image that you just saw me build. So it's right now currently only lives locally. Cat demo version 3. Now, what this is going to do is it's going to take the container image that you just saw me build, and you're going to see me push it out to my private repository, the same way that you normally distribute container images. You push and pull them between various different machines. After it's finished pushing all of the various layers up to the registry, it's going to then start to push the signing data associated with this image. Now, I've already set up the cryptographic keys. I've taken the public key of my user and I've stored it in the notary server. And the private key of my user, I've kept locally on my Windows 10 machine. And that private key is what I'm using now to sign the container image. Quick passphrase for my key. And there we go. So what has that actually done? If I now switch to my container registry, refresh. Okay, what you can see now inside of here is that I actually have some container images, 1, 2, and 3, and 3 was actually just pushed up. Inside of it, you can see that I have, first thing, a signed banner. That shows that inside of DTR that this was a signed container image. I could even inspect this to actually see who has signed my container image. So if I have a quick look back in the CLI, I could do Docker Trust inspect and just put a pretty flag to clear up the JSON. You can now see from the output of this command, you should be able to see all of the container image tags inside of my registry and who it is that signed them. So you can see number 3 was one that I just created and signed myself. And it was signed by admin. I'm using the admin keys here to sign that container image. You can actually sign a container image with multiple different people. So the signer could be the developer and the security team. or it could be the developer, the security team, and the pipeline. As well as signing container images and storing that signing data here inside the registry. You also would have noticed that there is a column here around vulnerabilities. I talked about before that one of the key concepts we have here is scanning container images for vulnerabilities. And if I look at this in more detail, you can see that what's happened is that we've broken down the container image into its layers. We talked about the layers of a container image before. And each layer of a container image, we've inventoried out its components. So you can see that in the base layer of a container image, it has these various components. It's then taken that inventory and compared it against a local CVE database. And so the first thing it said is, well, the version of OpenSSL you've used, that's got some vulnerabilities. Looking at it in more detail, it's got these 4 CVEs. And I can even click the CVE, take myself off to the public, to the CVE websites to actually understand more about the CVE. And if that's something that I want to accept inside of my container image. You may look at this and go, okay, it has a vulnerability. However, that's something that I've patched in a higher up layer, or that's something that I'm willing to risk on. But you now have that information front of hand. Today, you don't really scan, I don't know, virtual machine file systems looking for the binary libraries that you've got lying around. But we're able to do that in the packaging format that is the container image. And then, of course, we can start to build automation around this. I talked before about how you may want to then, I don't know, promote container images to testing repositories or production repositories, depending on the scan results. At this point, maybe as part of your automation, you may say, okay, I think I'm going to send a notification now back to the developer to say, work back on your image, patch the vulnerabilities, push it, go again. This image is not going to make it forward to the testing or to the production stages. Okay. So moving on, so we looked at how to develop container images using Docker Desktop Enterprise. We also looked at how to securely distribute container images using Docker Trusted Registry. We're now going to look at how to actually secure container operations and how to secure your container clusters. So by default, inside of Docker Enterprise, we actually do an awful lot of work to secure the underlying container cluster. There are some things that we want to make sure that are enabled the second you provision an environment. Whether that's cryptographically identifying each node with a unique ID, or enabling TLS between all node-to-node communications. So therefore, if anybody was trying to listen in between any of the infrastructure chatter in your nodes, they couldn't. It's all TLS encrypted. Or whether we wanted to handle the certificates and the certificate rotations between all of the nodes inside of your Docker Enterprise environment, which are key concepts in securing the underlying platform. They're all handled out of the box in Docker Enterprise. A lot of these concepts come from Docker Swarm, and we've talked about previously how we run both Docker Swarm and Kubernetes inside of your environment. And we actually leverage Docker Swarm to distribute and to provision and manage the lifecycle of Kubernetes. So all of these key security controls are enabled for both orchestrators. Actually securing Kubernetes inside of Docker Enterprise a lot more securely than is done in an upstream deployment today. As well as that, inside of Docker Enterprise, we spend an awful lot of time looking at the role-based access control and working out how to restrict who has access to your environment, the level of access they do have, and to what resources they have access to. This is done through 3 clear concepts. first one being user management. Docker Enterprise can be integrated back into Active Directory infrastructure, LDAP infrastructure, or SAML v2 environments. So if you wanted to manage the users and the teams centrally, that can be done. So if you wanted to say, I want to have application team 1 access to the Docker Enterprise environment and operations team 1 access to the Docker Enterprise environment, well, that can all be handled today via the Active Directory environment. You don't have to worry about manually creating users and having stale users lying around as the Active Directory environment matures. You have fine-grained roles inside Docker Enterprise, and you can start to take some of the pre-baked ones we have in the platform, or you can start to build your own roles to understand exactly what a user has access to. They could be roles like view only, they could be roles like they can get log information out, you can have roles like you can deploy. However you want to mix and match this, every API call in Docker Swarm, and in Kubernetes is exposed in our platform, and you can choose what users have access to what API calls. And then finally, we can start to group resources. Now, the grouping of resources is done in Docker Swarm by a concept called collections, and is done in Kubernetes via a concept of namespaces. And now we get to start to pair all of these things together. So we could take application team 1 as a user group. We can give it the operator role, and we can give it to the resource set of only application team 1's containers and pods. Therefore, you know exactly which users have what access to what group of resources, stopping application team 2 users having access to application team 1's containers, all enabled by default inside of Docker Enterprise. We can even start to secure the communication between containers, providing additional layers of network security above the underlay network. Whether that's network encryption on both Swarm and Kubernetes, or via network isolation powered by Calico. Inside of Kubernetes, we can actually start to control what containers can talk to other containers, whether that is inside of the same namespace or whether that's between namespaces. So you could say container 1 can only talk to container 2 through port 80, or you can say nothing from application team 1 can talk to application team 2. I want to completely lock down all communication between those two resource sets. Now, they are virtual namespaces. They're not physically isolating hardware or physically isolating networks, kind of like using like a VLAN or anything like that. These are software controls applied at the overlay layer to stop things happening. So it's to stop to application team 1's containers talking to application team 2 if there's any level of compromise or anything like that. Using our RBAC model, using the namespacing concept, using the network isolation concepts, you're able actually to create a very secure single multi-tenant environment, allowing you to trust that application teams can work side by side using the same container platform, maybe using the same underlying infrastructure, but have faith that there is a security model inside of the platform to stop, to isolate each tenant. Now, there may be reasons why you need to have multiple environments between, pre-production and production, and dev and test and production, that you want to have air-gapped clusters, and that completely makes sense. But the security model here provides you to have multi-tenancy on a single cluster. And then finally, one of the other key concepts built into Docker Enterprise is the runtime of all of that signature process I talked about in the content section. If you were an operator and you're starting to apply controls over what can run on your cluster, one of the key things that you want to understand is you want to lock down exactly which container images can start in your environment. And this can be done through Docker Content Trust. Inside of Docker Enterprise, through a simple tick box out of the user interface, you can start to apply policies around which container images can run. So for example, on the left-hand side, somebody could try and run kubectl create, and straight away the response you get back is the image did not meet the signing policy. That's great from an operations perspective, locking down what runs on your environment. And this is all done through the signing and cryptographic key process you saw in the previous demonstration. So let's look at the runtime verification in action. Over here, I have my signed container images. And now if I jump to universal control plane, you can now start to apply runtime signature verification restrictions. So a little bit timed out, so I'm just going to refresh it. A minute or two to come back around. And then what we're going to do is we're going to apply image policy restrictions on the cluster, preventing exactly what container images can run inside of your environment. So jump to administrative settings. A minute or two to warm up. Jump down to Docker Content Trust. And here you can see a tick box. Run only signed images. Want to tick that? And then you can choose exactly what signed images to run, whether that is run signed images that have any signature, or maybe run signed images that start to have particular teams' signatures. So maybe that was run signatures from the QA team. So therefore, any container image can start in my environment as long as it contains a signature from this particular team. I'm just going to remove that. For this demonstration, we just want to show that runtime enforcement works. So I'll save that. Now I'm going to start a container on Docker Enterprise. To do that, we have the idea of user certificates. We talked a little bit about that in previous sessions, but every single user inside of Docker Enterprise has a concept of a client bundle. A client bundle are certificates that are unique to a user to authenticate them against the environment. So if I jump to command line, just change directory 1 second. Change to the admin user. I can see that I have the client bundle unzipped in this particular directory. Client bundle contains unique certificates as well as scripts to source the certificates to my local environment. So if I source the certificates, if I did a command like docker node list, I would no longer be talking to Docker Desktop Enterprise. Instead, I'll be talking to the Docker Enterprise cluster running inside of this environment. But I'm not having to do kind of all of the user management was handled by Docker Enterprise. Creating the user, distributing the keys, deciding what role that user has, in this case admin, and defining what resource set that user can see, in this case, most strings. Now, if I want to start a container image, hopefully my image policy will prevent me. So if I did a Docker service create, okay, I'll give it a name, and I want to test this works. So I'm going to try and use an image available on the internet. I'm going to try and use the Nginx container image. There's nothing special about this container image. It's just one that is published on the Docker Hub, but it's one that does not contain a signature. I've not built it. I've not verified it. Straight away, it comes back. The image did not meet our signing policy. It hasn't got the relevant keys as part of it. So what happens if I try and start up the container image you saw me build earlier, cat demo 3? We've already tested to make sure it's got the right keys against it. Perfect. We can now start to see that it's deployed. Because it contained cryptographic keys from a local user, it is able to be deployed on my cluster. As an operator, I can now stop developers deploying container images from the internet, and instead only deploying container images from my local registry from a verified publisher. Even if I jump to the user interface, assuming it wakes up a little bit, let's open a new tab, see if that helps. We should actually start to see that service is now running. And we're also able to do a little bit of a cross-check. And that cross-check is where the control plane is talking to the registry. This is done to actually start to provide a list of what services are running inside of my environment, as well as you can see, we can start to bring across what vulnerabilities are running inside of my environment. So demo 2 was the one I just started. And you can see here that there is actually vulnerabilities associated with that container image. The control plane has talked to the registry and has said, what do you know about the container image? Well, the first thing it knows is it's got a signature and signature is passed. The second thing it knows is it's got a list of vulnerabilities. So if you ever, as you start to go forward and as images get rescanned every day when the new vulnerability database comes out, you can actually start to see if the container images you're running inside of your environment are still secure. And over time, you'd expect them packages to contain vulnerabilities as you start to, as you assume to start to patch container images as you go. Okay. So just to summarize here, we've been able to use the full breadth of the Docker Enterprise Container Platform in those demonstrations. We use Docker Desktop Enterprise to securely deploy a development environment for my developers. I then used Docker Desktop Enterprise to create a container image, sign it, and push it off to Docker Trusted Registry. I've used Docker Trusted Registry to store my container images, as well as to store the cryptographic keys. And then finally, I've used the universal control plane to run my container environment, not only providing a secure place for my users and my user management, I've also provided runtime verification that the signature that the developer used is good and provides runtime enforcement on my environment. That end-to-end story has put us in the top right-hand corner of the Forrester New Wave report. So feel free to click on that link and go and have a good read around Forrester's views on enterprise container platforms. Thank you.
Thank you, Oliver. We will now open things up for Q&A. We have Shaker Gilbert, Docker Senior Solutions Engineer, on hand to take your questions. So if you haven't already, please post those questions in the questions panel. Shaker, do we have any questions coming in that you would like to share?
Well, there's actually quite a few questions. Some of them are around Docker Desktop Enterprise. So I just want to kind of quickly touch on that. So Docker Desktop Enterprise is the tool that Ollie was talking about that allows developers to build their code and lock down the resources that they're using in order to interface with the Docker Enterprise platform. In order to set a lot of those defaults and enforcements for what users are allowed to use, the resources they're allowed to use, and how they interact with the Docker Enterprise platform, they're going to use an admin.settings JSON file that kind of ships along with the install package for your Docker Desktop Enterprise, and that can be modified and enforced at install time. That helps lock down the ability to use those services. There's also a couple of questions really around Notary. So Notary is open source. If you want to go to Docker Hub, you can just do a search for Notary. You can pull down the Notary client and the Notary server. If all you want to do was sign and push images, you could use those processes. It is part of Docker Content Trust, is part of the Docker Trusted Registry. So there's no additional software that you need to plug into that. You would use your regular Docker engine. You could use Docker trust commands, which simplify the Notary client commands, and sign those images. Multiple people can sign those images and have those pushed into DTR, you will need a notary server of some sort that's running in your registry. If you're not using Docker Docker Trusted Registry, you'll need some sort of notary server in order for your third-party registry to read that and to support it. So got a lot of questions around those, but I can open up the floor if there's any questions anybody has. And I guess I should say, do we open up the floor or do we just look for the questions?
Actually, yeah, with a group this size, we'll just have to go through that questions panel. So if there's a couple, we have probably about another 5 minutes. If there's a couple that you want to pick from the questions panel that are pouring in now.
Sure. Well, yeah. So one question, can Notary be installed as a container on Docker EE and K8's clusters? It doesn't have to, right? So Notary is part of Docker Trusted Registry. If you're getting Docker Enterprise, you already have Docker Trusted Registry, and you can sign images regardless of their orchestration methodology. So if you're deploying your images via swarm mode, those are still signable. And of course, if you're deploying your images using Kubernetes, those images can still be signed. Yes, you can. There's not necessarily, there's a question about whether or not there's an image for Notary server. You can, yes, you can just go down to the, I guess, go to Docker Hub, you can pull that down. Let's see. Let's see at runtime when containers talk to each other, how to verify their counterpart, SSL or something like that. I'm not quite clear, Jason, what that question is. If you want to kind of specify that a little bit further, I'd be happy to address it. Typically, when you have multiple images that you want to tie together, those images will be part of your service or your deployment, depending on, again, which orchestrator you're using. And then service discovery will handle all of that. If you need to validate or verify the images that need to communicate to each other, you could build that into the image model or secret. It needs to pass to the other application for it to bind to.
We have time for probably just about two, 3 more.
Yeah, sorry, I'm just scanning through here. What are some of the areas Docker's looking to improve on security? Well, security has always been a big part of what Docker is offering and what our core focus has been on. We believe that a true end-to-end security really starts at Docker Desktop Enterprise, and that's why we're going to be talking a lot more about that at DockerCon coming up as well. But it's one thing to build an image and secure it as part of the package that you're pushing to DTR, but we need to also do some sort of signing and enforcement between end to end, right? So if we can focus on end-to-end security starting at the desktop and then do enforcement at production, we can build secure pipelines through the entire chain, and that's really what we're focusing on. Any vulnerabilities that are also detected within the packages, we try to get on those right away. I mean, there was recently a vulnerability in Container D, and within a couple of hours, we were addressing it right away. So we really focus on ensuring that our platform is protected and definitely ensuring that our customers are protected. So Docker Hub, the images that are usually signed on Docker Hub are really the images that are provided by the official sources. Under private owner or private collections of Docker Hub, you can have signed images that are associated with your private registry. Public registries don't have signing capabilities because there aren't any account management layers. So we need the account management layers to enforce signatures. When CVEs are detected for a container image, say the image may relate to read-only layers. So CVEs, the databases that you're downloading into Docker Trusted Registry, it's scanning the image themselves, and all images are read-only until you deploy it as a container. So there's no, as Ali was saying, there's no read-write layer on an image until that image is spun as a container. You can think of it as a copy on write snapshot, right? If you're familiar with like how virtualization technologies work, right? So the image is one thing, and then you're creating a snapshot of it. So now there's a read-write layer on top of it, but CVEs are scanning all the read-only layers, right? So all the actual image layers that are stored in your registry. The database is updated every day. It's an automatic update into your DTR. If you're on a dark site, we have a lot of customers that are in a dark site or sites that are not connected to the internet. They can fetch those databases down daily as well. There was also a question on should you check what's the frequency of checking CVEs against images that are already contained within DTR. And so what you would do is you could set an API call in your CI/CD pipeline, like Jenkins or whatever you're using, so that it runs this API call, let's say every day, and it will just do a check and scan. When it does a check, what it's doing is it's comparing the database quickly through the manifest. It's checking the database based on the layers that are already scanned. If a layer has been modified, or if a layer has been identified as containing a package that will need to have another scan to it, we'll scan that layer. Now, one additional thing is if a layer is scanned in one package, every matching layer that's shared within that DTR will also be updated. So it's a lot faster once you start loading your images into the environment. So for removing vulnerability, rebuild image is the option. I'm not really sure what that question is. Removing a vulnerability, rebuild image. Let's see. And Doctor,
Shaker, if you want to pick one more out, we're just about have 2 minutes left. We just want to pick out one more question.
Okay.
That's about what we have time for.
All right, let me look through here. Well, so I think that this is not really a security-focused question, but one that comes up quite often is really around, Ali demonstrated a lot of the UI, and as you start using the tool, I mean, the UI is really good for kind of checking over the health of your enterprise cluster. There's also a way to identify images at runtime in the UI that have been scanned, right? So I think that this is kind of critical for the ops teams. When you load in the UI, you'll be able to see all the images that have been pulled over and deployed in your enterprise, and then what the vulnerabilities are with those running images. So it gives you kind of an end-to-end view of what's running in your enterprise. So I think for ops, the UI is really good. And get a lot of information out of it and a lot of metrics out of it. But as you start moving further into the dev teams and everything, the UI is generally not where you're going to find yourself, because you're going to be doing your pipeline work, or you're going to be on the CLI, piping in code related to Docker Compose or Kubernetes YAML files. I think that's all we have time for, Melanie.
Yeah, we're at the top of the hour now almost. So thank you very much, Shaker. And thank you everyone for all your questions and being so interactive. If we didn't get to your question, don't worry. We will do a follow-up blog after the end of the webinar series to make sure we capture all those questions and answers for you. And again, I'll stay on for another minute. If you have questions that you want to throw into the chat, I'll make sure to save those and get those recorded so we can answer those. But we are at the top of the hour, so this does conclude our webinar. Just a reminder again that today's session was recorded, and you will receive a follow-up email to view that recording in the next few days. And again, we thank you for joining us, and we hope to see you next week at the next webinar series number 4. Thank you, everyone. Have a terrific day.